Hello everyone and welcome. This is Construção, your number one podcast on civil engineering topics. My name is Vitor Lima. Joining me as the co-host for the episode is Giovanna Martins, and today is our 41st episode in which we'll discuss universities' contribution to innovation in the construction industry in the USA. Giovanna?
Hi guys, today with us we have Fernanda Leite, who is a graduate of the Federal University of Ceará. She holds a master's degree in engineering from the Federal University of Rio Grande do Sul and a PhD in civil and environmental engineering from the Carnegie Mellon University. Currently, she's a professor in the Department of Civil and Environmental Engineering at the University of Texas at Austin. Actually, she holds the title of the John A. Fox Continual Teaching Fellow in Civil Engineering. Aside from that, Fernanda is the former president of an interdisciplinary research initiative called Plant Texas 2050. And is an associate editor of this Automation in Construction journal. She has experience in the field of civil engineering with an emphasis in civil construction, focusing mainly on the following topics: construction management and economics, computer engineering, simulation, building information modeling, more known as the program BIM, and artificial intelligence applied to civil construction.
Thank you so much, Giovanna. And after this introduction, Fernanda, could you share a little bit more about yourself, your past experiences?
Sure. So first off, thanks for having me here today. It's a pleasure to be talking to fellow Brazilians in this podcast. So I've been here at the University of Texas for 14 years. So I joined right after I finished my PhD at Carnegie Mellon. I grew up partly here in Texas. So Texas for me is probably the closest thing to home. I grew up here. I spent 7 years as a kid here in the state. My father got his master's and PhD here in Texas as well. So it's a great place to be, and we have a lot of connections with industry. The one thing that I have been working on and I focus on in my research is really technology applied to construction projects, to the delivery of capital projects. So I very much have been heavily engaged with the Construction Industry Institute, which I'm happy to speak more about, but it's an industry consortium of 130 member companies. So these are large contractor companies, owner companies, service providers, mostly in the EPC sector, so heavy industrial projects. And CII has existed, or they just celebrated its 40th anniversary. So I'm part of I just stepped down of CII's strategic planning committee because of my transition into administration. So I just began a new role at the university as associate dean for research. So what this means is that I oversee all of the research in the entire Cockrell School of Engineering. So we're composed of 7 departments. So civil engineering is one of these 7 departments, and we have 17 research centers, of which CII is one of the 17. So now I'm doing a lot of learning on the other 6 departments and the other 16 centers in the Cockrell School. So we have about 6,000 students in the School of Engineering and 300 professors. So I oversee all of that. And so my role as Associate Dean for Research is not just overseeing the research mission, but also I oversee all of facilities and construction. We're always building in the School of Engineering. Right now we're building a brand new building, which will be the new home of the petroleum engineering building and the chemical engineering department. So both departments are moving into this new building that I'm overseeing. And we're building a 65,000 square foot, which in meters would be about 6,500 meters, square meters of a chip manufacturing plant. So with the pandemic, the U.S. government has made significant investment in the semiconductor industry. So we're now building a chip manufacturing plant here as part of the university, in a smaller version that's going to be used for research, about 1,000 square meters. So I oversee research and facilities and construction in this new role. So it's quite a big challenge for me, but I'm enjoying the challenge. The one thing that stayed from my past work, or my past job, let's put it that way, is my role as a PhD supervisor and a researcher. So everything else I had to give up. I no longer teach, which I'm a little bit sad about, because I enjoy teaching, but something's got to give. But the only thing that stayed is my work with my PhD students and the active research projects that I have right now that I'm happy to talk a little bit more about. But that's a little bit about myself.
Perfect, amazing, and that's a lot. Thank you so much, Fernanda. That's very, very interesting. And now I think we can go ahead to the questions, okay? So the first question I want to ask you is more like a request. So could you please share some insights about all the researches being conducted at the University of Texas?
You mean my research or the entire School of Engineering?
Well, first of all, let's go with your research.
Okay. My research sits at the interface of computing and engineering. So when I went to Carnegie Mellon for my PhD, that's a school that's very well known for its computer science department. So during my PhD, most of my courses were in computer science. So I did a lot of data modeling, information modeling, and that's how I got into building information modeling, or more broadly speaking, virtual design and construction. So that's, I would classify, or I would categorize or put my research into two big buckets. One bucket would be this technology and construction, or virtual design and construction. And then the other bucket, which is more recent, I would say in the last 5 years, I've been transitioning my research more towards sustainable systems engineering. So I even created a new program. It's a new master's and PhD program here at the School of Engineering called Sustainable Systems Engineering, and it's a cross-disciplinary program for students that are more interested in working across traditional disciplinary boundaries of civil engineering. So I led that program for several years, and I still have a couple of PhD students that are out of that program. And a lot of my more recent research projects are under that theme, that general theme of sustainable systems engineering. I would say that the more recent one that I can elaborate a little bit more on, this is a Department of Energy. This is Department of Energy is a part of the federal government, the U.S. federal government. We started a 5-year project called Southeast Texas Urban Integrated Field Lab. So we're building a field lab collecting field data in Southeast Texas, which is an area where there's a lot of refineries. So Texas is well known for its production of energy. There's a lot of refineries, a lot of industries in this region, but it also is an area that's very prone to flooding and suffers from air pollution because of the industries there. So where our team is very cross-disciplinary. It's 5 different universities, a national lab, about 29 senior personnel, so 29 researchers, not even counting the students. These are the senior personnel. So it's pretty large, the team, and we're leading it here out of the university, and I'm working on 2 pieces of it. So we have climate scientists, we have water modelers, air quality modelers in the team. My work is in information modeling and integration. So I'm developing with our supercomputing center, which is also part of the university, what we call a knowledge management platform. And this platform will integrate these flood models, climate models, and air quality models, so that we can then design climate resilient infrastructure systems, considering these uncertainties that will happen in the next 30 years, and engage the community and local stakeholders in how we can better design infrastructure to address these impacts that will happen in the coming decades.
Excellent. Amazing, Fernanda. I think that's very, very interesting indeed. And is there any other project that you're not a part of, but you think that is good to give a highlight to in the university?
Yeah, so there's several. So in I would say the Cockrell School of Engineering has a lot of very large cross-disciplinary research initiatives. One is a new research center that just got renewed that's focused on material science engineering. So a lot of people from chemical engineering involved in this center. And the other one is one that just got funded also by the Department of Energy, that is focused on decarbonizing or electrifying the energy production process. So all of that is really that forward-looking way of how can we become more resilient and sustainable as a society. And it all starts with research.
Amazing. Thank you so much. And let's go to the next question, Giovanna.
So you just took on a big role in the university, and your research as well has a big influence, has a big impact, has a big group that you had to take care of. Being so in touch with the university, what do you think are some skills and competencies currently in demand in the University of Texas for programs like 3D modeling, through BIM, virtualization, those programs that you yourself said you studied a lot?
Yeah, so I would say, just to provide a little bit of context, so I'm a lot of that virtual design construction in the built environment happens within the civil, architectural, and environmental engineering department. So our department, when we don't have the, so civil engineering is a major, like the two of you are getting a civil engineering degree. Our department also offers two other majors, which is architectural engineering and environmental engineering. Architectural engineering is not architecture. So it's so we still have a school of architecture like in Brazil. So the way that we separate it here in the US is architectural engineering is vertical construction, so buildings, and civil engineering are horizontal construction.
Wow.
And so that's why it's in the same department, because there's a lot of overlap between those two programs. So in terms of virtual design and construction, that's very prevalent in our vertical construction, right? So our architectural engineering program. So part of my role when I was hired here at the university 14 years ago as a faculty member was to integrate building information modeling across our undergraduate, so bachelor's degree. That's also something that's different in Brazil and the US. We say undergraduate for the bachelor's degree. Graduate is master's and PhD. So it's, it always generates confusion when people
Definitely.
it and they say graduate, but they mean undergraduate. So I like to clarify that. So our undergraduate degree in architectural engineering, my role was to integrate building information modeling across that curriculum. So that means that it's not just one elective course, it's got to be integrated across multiple years. And that program includes a lot of the technical, same structural engineering courses that the civil engineering majors take, but they apply it to high-rise construction. But they also have design, they're more heavily engaged in design studio courses because they do something called integrated design. That's what the major focus of architectural engineering is as compared to architecture. We do integrated design of building systems, of structural elements, of mechanical, electrical, and plumbing systems. And that's why BIM is so important, an important part of that, because it enables more efficient collaboration across different team members. The way that projects are delivered in the US, it's a little bit different than in Brazil. So in Brazil, you typically have like an owner developer of a project, let's say a high-rise project, right? The owner company, the construction company is also the developer. And so they typically hire their professionals and they manage that entire process mostly in-house. Here, the industry is very fragmented. So you typically have an owner, which is not necessarily the constructor, the contractor, right? The person that's going to build that. And then all of the designers are also different people. You have the architectural engineer that designs the architectural scope. Then you have the structural engineer. Then you have the mechanical engineer, plumbing engineer, electrical engineer, and so forth. And all of these designs are done typically in silos, and that's why design coordination is so important, and that's why it's done now. Most projects here in the US, if it's above 5 million, it's going to be using BIM for design coordination, and mostly for these MEP systems. Most buildings here, when I see Brazilians that come and visit construction projects here, one observation that I hear commonly Brazilians say is, oh, there's so many building systems. The buildings are so heavy in building systems, and that's true because we all of our buildings are conditioned artificially, the entire building, right? So it's all via ductwork and via those different systems. So it is a lot heavier in the system side than what you would typically see in Brazil per se.
So regarding those programs, for students that are looking to go to the University of Texas, what are some skills or something they can do to improve their chances to stand out more in the university to enter there?
But do you mean at the undergraduate level or at the graduate level?
Both.
Okay, well, at the undergraduate level, they start green anyway. They come out of high school, and a lot of high schools will have 3D modeling programs, will have computing programs. I think one of the things that would for us, where we're looking at really changing the curriculum, and from a computational standpoint. So starting to teach computational thinking from the first year in engineering. And this is at the undergraduate level, because we know that if we want to work with large complex projects, we can't do it how we've been doing it all these years, right? We need computer models, and therefore we need to be able to communicate more effectively with machines. And so that's why it's so important to understand computational thinking. And most high schools here will teach computer programming. And so most of our students will already come in with knowing some computer programming language, because a lot of our classes will require that if they're doing, let's say, structural analysis, or even generative design. If you're doing a design studio courses, those use visual programming. So computational thinking will really help students excel. And at the graduate level, even more so. I think at the graduate level, we don't use off-the-shelf software systems. We create software, we program them, we develop these programs, or at least proof of concept. So our students have to be really good at, especially in the area of virtual design and construction, computing and civil engineering. They're really, really good at programming. They're really good at machine learning, at deep learning, at artificial intelligence. And it's not applying, and that's the main difference that I think a lot of people think, oh, if I know how to use this 3D modeling software, I'll do great. Nobody cares. Everybody knows how to do that. It's, can you program something like that? Can you create a new software system? Right. So it's at the graduate level, we're more about pushing the boundary of knowledge and creating new knowledge and creating new ideas. So it's not about using software, existing off-the-shelf software systems.
No, thank you. That's very enlightening. Victor?
Yeah, I think that the fact that that the university expects the students to create things kind of from scratch is something that is not seen a lot here in UFG or in other universities in Brazil, because here the focus is which programs do you know how to use. And I think that's kind of mechanized, like we are not machines, we should know how to think. And it's like using the programs, not really thinking about it. I think that's an idea that should be really focused and worked here.
And that is both in the academic level and the work environment as well. Yeah. There's not much incentive to think outside the box, to think new things. Just to know how to use what there is to use.
Yeah, exactly, Giovanna. And Fernanda, for our next question here, I want to know both what you see on the market and your opinion. So, what do you think that companies are investing in terms of technologies, in terms of innovation, and what do you think that they should be investing in? Like, do you agree with them, or do you think there's something else that they should be putting money on, but they're not?
Well, I think first off, companies are very strategic in how they invest in technology. So it's not about, let's say, I'll give the example of virtual reality, right? A few years ago, I developed CII, the Construction Industry Institute, commissioned a study on virtual reality in capital projects delivery. So what does that mean? They wanted a guidebook. So if EPC companies, heavy industrial companies, EPC stands for engineer, procure, construct. So it would be equivalent of, let's say, a design build for the building sector, but this is for heavy industrial projects like large refineries, for example. So they wanted a guidebook for EPC type companies to be able to start using virtual reality. So the first question that we asked was, well, we can develop this guidebook. We can tell you what kind of personnel you need, what kind of equipment, or at least the specifications, because we're not going to tell you exactly what the commercial names are, but we can give you the specs. We can give you the tools that you need for your people. But most importantly, you should be thinking strategically, how are you going to implement this company-wide? So the big challenge with a lot of technology that I see is that, and I call it the squirrel syndrome. So here in the US, we have squirrels, right? The animal squirrels. And when a little dog sees a squirrel, they just run after it, right? So that also goes with technology. You see this cool new shiny toy. Oh, I want to test it out in my project, right? And you test it out, and that becomes a one-off prototype. If you don't think strategically, how are you going to implement that company-wide or throughout multiple projects? It's just going to be a one-off play, a one-off, experiment. And so then you see a new technology, and then you go off and chase another squirrel, right? With this virtual reality study, going back to that CII study, we really looked at what are the appropriate use cases that you should be using that technology in versus, for example, augmented reality or mixed reality. There's other visualization technologies that might be appropriate. Sometimes pen and paper will do the trick, right? So just because it's a digital technology doesn't mean it's the best solution to solve the problem that you're trying to address. So I think it's most important to identify what is the problem you're trying to address, then try to match that with the appropriate solution to identify that problem. And if you're thinking about, again, going back to the example of virtual reality, the biggest commitment in terms of cost is not the technology per se. It's not the equipment, not the headsets, not the machines. It's personnel time. So that's the biggest investment. And if you think of the amount of time that it takes to develop a virtual reality experience for an engineering project, most of the time is in that development. So if you think strategically of how you're going to implement that specific type of technology in multiple projects, you can then do a development approach that would apply to across an organization to multiple projects, not one that's custom made just for one project. So then when you have another subsequent project, you have to start from scratch. And then you have that long development time again. So if you think strategically, you can then begin to implement these or invest in a development time that can apply to multiple projects and not just to one. So I think that's the most important thing, is to really think holistically about technology and think about it from start from the problem and not from the technology. Because there's a saying in the US, if you have a hammer, the technology, everything starts looking like a nail, and then you can break everything around you, right? So I think it's much more important to identify those problems, those nails, right? And then you identify what's the best tool to address that problem.
Yeah, definitely agree. I think that the hammer metaphor is a perfect example of knowing which tool to use. Maybe the hammer is not the best option. So I think that's something that is really good to be considered. And I think that we can go over to our next question and last with Giovanna.
I would like to ask again regarding your opinion and what you believe is the biggest obstacle to implementing those mindsets to enable the implementation of new technologies, and the process and the scenario in which you operate, and how you can overcome those very obstacles that you just mentioned.
Well, I think the model that for example, CII has adopted, which for over the past 40 years, CII has brought together subject matter experts, so industry leaders that are leaders in different areas of construction engineering, and academics who understand research processes. Bring them together to really solve problems or to push the industry forward as a whole. That creates an environment in which you can have a more structured approach towards the development of these new ideas, right? And you're bringing together people that are day to day working in those problems, and the academics that have that structured approach of doing this. So I think that it's great to try new things, to be open to new ideas, but it's also very important to think strategically when you're implementing new technologies, not just try things out for the sake of trying things out, but really asking yourself, why am I doing this? How is this going to improve the process that I'm trying to address? And what are the other alternatives, so that you can evaluate what the outcomes are. When you evaluate or when you test out that specific technology, you can also test alternative technologies to then make a more informed decision of what you want to invest in the long term. So I think it's about having a more structured approach towards the selection of technologies.
Which of those obstacles do you think you have seen up close in the university? Do you think, oh, this is the one I recognize most inside the university, inside the program that I'm conducting in your role?
I'm trying to think of obstacles to technology implementation.
No, when you implement a new system, a new technology, when you have to pass it on to students, or students show up with some new projects, what is the biggest obstacle to implement, to analyze, to integrate or not in the university?
Well, I think the people side is always the most challenging. It's not learning technology, it's not learning how to implement it, but it's learning how to work collaboratively in teams, and that goes for professionals as well, right? So if you're implementing something new, change management. Change is the hardest part. Dealing with change and doing something differently than you have done before is the hardest part. So I wouldn't consider technology as the barrier. I would consider that the enabler. But barriers are how people are leveraging that technology or how they're collaborating. Usually, the biggest challenges that I have seen as an educator are students having to manage conflict within their own teams as they're working, or getting access to data to do some sort of research project that requires data, real world data. A lot of people are very protective of their data, especially in construction projects. So oftentimes getting access to projects may be a challenge, not just from a data security standpoint, but also from a construction safety standpoint. Many companies are protective of access to their projects because of all the safety regulations that we have to abide by as well.
Thank you. Really, the people are always the most challenging factor in every sector, it seems. The human factor.
Yeah, we sure. People are definitely a handwork. And Fernanda, with that, we wrap up our questions. So thank you so much for joining us. And now we would like to give you the room to give any comments, any ideas to us, Brazilian students, and also all the international listeners that are listening to us. So can you give us a final idea, final thoughts?
Sure. Well, don't be afraid to try new things, right? And I think a lot of people may think, oh, it's maybe going to study abroad might seem like a pipe dream, might seem like something that's not attainable, but you never know until you try, right? So I think that if you're out there listening, if you're a student that you might think you might want to explore a career in another country, here in the U.S. at least, one of the best ways to enter the job market in the U.S. is by getting a degree in a U.S. institution. Not just because that makes visa issues easier, having a degree here and then staying on after your degree here in a U.S. institution, but also just understanding the culture and understanding how projects are delivered in a different way than in Brazil, how things are built differently, and every country has its own specificity. So there's a lot of benefit of getting a degree in a country that you would potentially like to enter the job market in. And there's just a lot of opportunities. Most of our students here in engineering, we have a 98% employment rate when they graduate. Most students will have multiple job offers. And there's just a lot of jobs in engineering, and not just in industry, but industry. The getting a degree in engineering gives you strong analytical skills, so you're able to do anything, any type of job, not just an engineering job as well. So I think that don't be afraid to try new things, and don't be afraid to explore different options, even outside of Brazil. I think the world is a big place, and you just gotta try to put yourself out there.
Thank you so much. One thing you said is that you don't have to work in engineering when you graduate in engineering. I think that is a constant in every country. Engineers don't often end up just in engineering. There are multiple job offers in multiple different areas, and I think that's just amazing.
Absolutely.
Well, For those interested in learning more about innovations in civil construction, listen to episode 38 with Brenda Araújo, Sávio Melo, and Alisson Souza, where we discuss the method for implementing the FE Smart system, a system with smart inspections for reinforcement in concrete elements. And thank you so much for tuning in this episode.
And thank you once again so much for joining us, Fernanda, and all of our listeners who are still watching and listening to us. So if you're interested in learning more about civil engineering as a whole or in our projects, in our latest episodes, you can join us at emconstrução.ufg. That is emconstrucao.ufg. We'll see you guys in the next episodes. Thank you so much for joining us. And Giovanna?
Thank you for tuning in Construção, your #1 civil engineering podcast.